So finally, we're going to look at some coordinate proofs. So this coordinate proof says that the coordinates of three vertices of a quadrilateral ABCD are AB, A, 3, -1, B, 10, 0, and C, 5, 5. For what coordinate of D will the quadrilateral be a rhombus? So for this, when I'm thinking of the coordinate plane, what I want are two sets of parallel sides and four congruent sides. So I'm going to start by doing my two sets of parallel sides. And then from there, we're going to test to make sure it works for the congruent as well. So I have side AB, BC, CD, and DA. So I don't know what D is. So I am going to wait on the bottom two. I'm just going to determine the slopes of the top two. So AB has a slope 0 minus -1 over 10 minus 3. I get positive 1 over 7. Then for BC, I have 5 minus 0 over 5 minus 10. I get 5/5, which is 1. So now I have to figure out how for CD to get 1/7 and how for DA to get 1. So what I have for CD is x minus 5 over y minus 5 equals 1/7. And for DA, I have 3 minus x over -1 minus y equals 1. So with these two, I could either guess and check, or I could do, what's it called? Oh my gosh. Systems of equations to figure out what these are, but I'm going to start with guess and check. So for CD, if I want a 1, then I would define that as x equals 6. If I want a 7 at the bottom, that would be 12. However, what could also give me 1/7 is if the top was -1 and the bottom was -7. So if I wanted -1, then I'd put my x at 4 and my y at, oh god, -7. -2 minus 5 would be -7. So my points are either 6 and 12 or 4 and -2. So that's what I'm going to test the second one. So if I did 3 minus 6 over -1 minus 12, I'd get -9. Sorry, not -9. -3 over -13. That's not 1. Trying the next one, I have 3 minus 4 over -1 minus 2 minus -2. I get -1 over 1. Now I'm seeing up here that this should have been -5 and this should have been -1. Sorry, y'all, mistakes. But now I have my point for D. So D should equal 4, -2. However, to make sure for absolute fact that this is a rhombus, I'm going to test two consecutive sides to make sure that their distances are the same. I'm going to do this in a different color. I'm going to do AB and BC. Minus -1, which is plus squared. So this top one gives me 49 squared, or sorry, 49 plus 1, which equals the square root of 50. Down here, I get 25 plus 25, which is the square root of 50. So they are congruent. So I know that this is correct. D would be at 4, -2. You're going to do a very straightforward rhombus proof. I've talked through this example, didn't have a traditional 2-column proof in it. It was just some talking through of some theorems. So do your best, apply your skills, and see what you can do.